Hey guys, welcome to another calculus tutorial by the Magic Monk. Today we're going to continue with anti-differentiation. The first thing I want to mention is that if you come across the term integration when the teacher tells you to integrate a function, it means exact same thing as anti-differentiation or anti-differentiate the function. Right, so for example, if you see the notation here, this can be said as anti-differentiate 5x, or you can say it as integrate 5x. It means exact same thing. As the last tutorial, you can use the formula to integrate this, and that gives you 5x squared over 2 plus c. In other words, 5x squared over 2 plus any number you want will differentiate into 5x. So let's try that. So if y equals 5x squared over 2, let's say plus 15, or you can put any number here, then dy over dx is equal to 2 times 5x squared over 2 plus 15, and this 2 divided by 2 cancels down to 1, so it's 5x squared, and the 15 is a constant, so it disappears when you differentiate it, and here's the answer. Okay, so the next thing we want to do is some more complicated examples of integration. So feel free to have a go at these questions and come back when you're done. Okay, the first question, what I'm gonna do is firstly change it to, I'm gonna move the denominator to the top by using the index laws. So this, before we even integrate it, I'm gonna write it as 8x to the power of -2, because when you move a term from the denominator to the numerator, you have to change the power to the opposite sign. So this was originally positive, I'm changing it to negative. And then what I'm doing is still I have not integrated yet, and then I will integrate it after I have done that using the rule. So the rule is 8x to the power of -1, because -2 plus 1 is -1 over -1 plus c. Now 8 divided by -1 is just -8, x to the power of -1 plus c, and I'm going to move the x back to the bottom of the fraction just to make it positive. So that's the answer, -8 over x plus c. And if you want to check whether you have done it right, you can differentiate it again. So if y equals -8 over x plus a random number, any number you want for c, let's say 4, then dy over dx, which is the derivative of y, will give you, or firstly I'm going to change the y to -8x to the power of -1 plus 4. So then the derivative of that will just be -1 times -8x to the power of -2. The plus 4 is gone after you differentiate it, so this becomes 8x to the power of -2, which is 8 over x squared, which is what we had before. So anytime you want to check whether you have integrated a function correctly, all you have to do is differentiate your answer again to see if you can get the derivative. Okay, question 2. Again, we want to move the denominator to the numerator position, and as well as having to change the square root sign into just a normal power. So what we want to do is, before we even integrate it, get rid of the square root sign. So this becomes x to the power of 3 over 4. So this was one of the index laws. If you're not sure how I just did that, you should go back to the index law tutorial. Okay, now I can move the denominator to the numerator position. So this becomes 3x to the power of negative 3 over 4 dx. Now, for those of you who like decimals better than fractions, you can also express this as negative 0.75 dx. Right, because 3/4 is the same thing as 0.75. And now we use the index law, the integration law to differentiate it, to integrate it. Then this becomes 3x to the power of negative 0.75 plus 1 over negative 0.75 plus 1 plus c. So now we have integrated it. That's when you get rid of the integral sign. Okay, the next thing you want to do is make sure that you simplify it. So this becomes 3x to the power of 1 minus 0.75 is 0.25 over 0.25 plus c. And obviously 3 divided by 0.25, you can simplify that as well, which gives you 12x 0.25 plus c, or if we want to change this back into fraction form, so this becomes 12x to the power of 1 over 4 plus c. And if you want to check that this will differentiate back into your derivative, so we do a little check to make sure we have done the integration correctly. So if y equals 12x to the power of 1 over 4 plus c, then dy over dx will be equal to 1 over 4 times 12x to the power of 1 over 4 minus 1. C is gone because c is a constant. So this becomes 12 divided by 4 is 3x. 1 over 4 minus 1 is negative 3 over 4. Alright. And then, of course, if we move the x back to the bottom, then this becomes x to the power of 3 over 4, which is 3 over x to the power of 3 to the 4th root. So that is what we had in the beginning, hopefully. Is that what we have in the beginning? 3 over x to the power of 3 to the 4th root. So that makes this our answer. So let's tick that. Okay, so we've done 2 questions now. Let's get to the 3rd question. So here we have something in brackets to the power of 2. Now, we haven't learned how to integrate composite functions. If you remember, we can differentiate composite functions, but we haven't given you the rule for integrating composite functions. So what that means is we're going to have to expand it first. So then this becomes 2x times 2x, 4x squared. Plus 1 in the end, and then negative 2x minus negative 2x is negative 4x dx. And now we can just integrate it quickly using the integration rule. So that's 4x3 over 3 minus 4x squared over 2 plus x plus c. Okay, because 1 integrates into x, because let's say we have x to the power of 0 here, so 0 plus 1 is 1, so x to the power of 1 over 1 is just x. Okay, so simplifying that a bit better, so it's 4x cubed over 3 minus 2x squared plus x plus c. And you might want to do the check again. So if y equals 4 over 3 x cubed minus 2x squared plus x plus, let's say, any number, let's say 6, then dy over dx is equal to 4 over 3 times 3x squared minus 4x plus 1, which is 4x squared minus 4x plus 1, which is can be factorized into 2x minus 1 squared. Okay, so hopefully you guys have learned something from this tutorial. See you guys next time.